Find and graph all fifth roots of 1024 cis 100. I like to write it like this. Because to me, it makes it obvious that I'm going to take both sides to the 1/5 power. I'm going to use de Moivre's, and what you have to do is take 1024 to the 1/5 power and then 100 times 1/5. So on your calculator, 1024 to the, you got to put your fraction inside parentheses here. Otherwise, it would only take it to the first power. But to the 1/5 power, that's 4. And 100 times 1/5 is 20 degrees. So x equals 4 cis 20 degrees. 4 cis 20 degrees, we just have to eyeball it, I guess, because 20 is probably like right there. But 1, 2, 3, 4. That's 4 cis 20. Now, you also have to realize that if we're doing the fifth roots and find all fifth roots, there are 5 of those roots. And so the nth root theorem, the first part of the nth root theorem tells me what the first one is, 4 cis 20. But then the next part tells you how to get the other 4. If there are 5 solutions, they are spread equally throughout the plane. And 360 divided by 5 is 72 degrees. What that means is each of those vectors is 72 degrees apart. So what I can do then is take that first one, 4 cis 20, and just add 72. So there is one at 4 cis 92. And then if I add 72 again, (164). So 4 cis 164. And another one. And then a fifth one. 236 and 308. So I've got 5 solutions there. 4 cis 20 was the first one. 4 cis 92. 1, 2, 4. And 164. And 236. And 308. Now, if you've done this wrong, you'll know because they won't be equally spaced. All right, that has to be 72 degrees, 72 degrees, 72 degrees, 72 degrees, 72 degrees. And if they're not equally spaced, you'll know something's messed up. But there we go. We found the 5 roots and we graphed them. So then the next one, you've got to find all cube roots. So cube root of 216, 216 to the 1/3 power. So cube root of 216 is 6. And 270 times 1/3 is 90. That's the first. That's the first of the 3 solutions. But since there are 3 cubed roots, they must be 120 degrees apart from each other. So just add 120. That would be, what, 210? And add 120 again to get the third one. Those are your 3 cube roots of 216 cis 270. So 6 cis 90, 1, 2, 3, 4, 5, 6. And 210. Remember, direction and magnitude. 330. Now again, those things should be equally spaced. If not, it'll be obvious, but 120, 120, 120. Solve each equation. It's basically the same thing. We're finding the roots, okay? Find roots, all of them. In this problem, there are 3 answers. In this problem, there are 4 answers. In this problem, there are 2 answers. There are 2 roots, 4 roots, 3 roots, whatever. So students kind of struggle with this one. You'll really want to think about this because there's a conversion that's necessary. Ideally, you think about it as isolating the variable. That's what we're doing. Solve the equation. So I subtract the 125 over. But students are really bad at thinking of this as a vector, and that's what you want. You want to look at this as a vector with magnitude and direction. Right now, I can think about it in rectangular form, negative 125 plus 0i, but students have a really hard time thinking about it as a magnitude and direction. Okay? They start thinking about the formulas, and they want to convert it to polar, so they start saying, well, r equals square root of negative 125 squared plus 0 squared. And if you have to write this out, I'm guessing you're not going to get this answer right. Okay? You need to be able to do this in your head, and the 0 is what makes it easy, I think. So square root of 125 squared, of course, that's going to be 125. And then tangent theta, this is hard. When you use the formula, it's a lot harder than it needs to be. Y over x. And so inverse tangent of 0, you can look at your calculator if you need to, but inverse tangent of 0 is 0. That's that's misleading because it's not 0. It's 0 negative. This is a 0 negative. You can't get this right without thinking about where this is. And so that's why I would bypass the green completely. I don't really look at the green. I just look at this thing and I say, well, that takes me left and neither up nor down. So, you know, if you're graphing negative 125, negative 125 is just left. So all I need is a magnitude and a direction. Well, that direction is 180. And so it's not 0, it's 0 negative. Theta is 180. So, I mean, you can use the formula if you want to, as long as you can interpret the location. This thing is to the left, that's an angle of 180. So my vector has magnitude and direction. But I haven't solved yet. I still haven't isolated the variable. I still have to take the 1/3 power. I still have to take the cube root. So cube root is just like we did on the last slide. Cube root of 125 is 5. 180 times 1/3 is 60. That's the first one of my solutions. Since there are 3 solutions here, that means they're 120 degrees apart. So just add 120 and do it again. Those are your 3 cube roots. Okay, now it's possible that you'd have to convert this back into rectangular form. If you had to convert this back into rectangular form, you'd just say 5 cosine 60 and 5 sine 60. 2.5 plus 4.33 I. 2.5 plus 4.3 I. And the next one, you've got 5 cosine 180 and 5 sine 180. That's negative 5. And cosine, or 300. 5 cosine 300 and 5 sine 300. 2.5 minus 4.3. So 2.5 minus 4.3 I. So you have to pay attention to what form it is. Yes? Okay, say that louder, please. Personally, yes, but the test is probably going to be multiple choice. So you just have to do whatever it says. Does it want polar? Does it want rectangular? Make sure you do what it says. Okay? So then the next one, add the 16 over and think about it as a vector. Okay? I don't want to use the formulas, even though I could. I could use the r and the theta formulas to find this, but I think it's much, much easier to just picture where this is. 16 to the right. So that vector is 16 cis 0. So I need to find the 4th roots. Okay, the 4th root, so take this to the 1/4 power. That's going to be 2 cis 0. 0 times 1/4 is 0. There are 4 solutions, So if there are 4 solutions, that means they are 90 degrees apart. So add 90, add 90, add 90. Incidentally, if you kept going and added 90 again, you'd get 360, which is exactly the same thing as the first one that we started with, okay? So if you kept going, you're going to go back around and overlap. So you have to stop at 4 because that's all there are. Next one, if you subtract 64i, you're going to get x squared equals negative 64i, but it's probably more useful to leave that 0 in there because we want to think about this as a vector. 0 minus 64i. Again, you could use the formulas, the r and the theta formula, but it's going to be a lot better if you just picture where this is, because 0 minus 64 says to go down. We're going down 64, and so all we need is a magnitude and a direction. That's 64 cis 270. We like polar because polar is going to be easier to do. X squared equals 64 cis 270. Try that again. So you can think about it as the 1/2 exponent, or this one's a square root. It's probably more useful to think about it as the 1/2 exponent. So you can think about this as DeMoss. 64 to the 1/2, that's the square root. That's 8. 270 times 1/2, it's 135. So that's your first one of your 2 solutions. But there are 2 solutions. If there are 2 solutions, then they are 180 degrees apart, so we need to add 180. So what is that, 315? 315. And again, if you had to convert it, you do 8 cosine 135 and 8 sine 135 and figure that out. Next, identify the graphs, okay? Identify the shapes of the graphs. So this is kind of a multiple choice matching type question. You need to be able to tell me what shape you're looking at without having to graph it, okay? So 4 cosine theta is a circle. Not only is it a circle, but it's oriented in the x direction. 1, 2, 3, 4. It looks like this. Circle in the cosine direction or in the x direction. 4 plus 4 cosine theta. When you see 4 plus 4 right there, you should know that's a cardioid. Cardioid. Okay, cardioid, or a heart shape. So this is also oriented in the x direction. If you add those 2 numbers, 1, 2, 3, 4, 5, 6, 7, 8, that's how far out it goes. Okay, it's going to go up 4, 1, 2, 3, 4, and down 1, 2, 3, 4. This graph's going to look like this. Keep in mind, it's circle-ish. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's a cardioid. Next one. You're looking at when how these 2 numbers compare to each other. Okay, and when this number is smaller, it's called a limison. Without inner loop. And by the way, this is also a special kind of limison, but it's got a special name of cardioid. But a limison without inner loop, and that looks like this. Okay, again, cosine, so it's pointing in the x direction. If you add those 2 numbers together, you get 7. 1, 2, 3, 4, 5, 6, 7. If you subtract those numbers, you get 1. That first number is 4, so 1, 2, 3, 4, 1, 2, 3, 4. This graph is going to go here and here and here and here. So keep in mind, it tries to be circle-ish. It's just kind of flat. It's kind of flattened on one side. That's not a perfect circle. It's a little bit pushed in or a little bit flattened. When this number is bigger than that number, that's going to be a limison with inner loop. So add those two numbers together, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Subtract those two numbers, it's 1. So this time you've got a 9 here and you've got a 1 here. That's where your inner loop is. That first number is 4. So 1, 2, 3, 4. 1, 2, 3, 4. You're going to have a limison with inner loop oriented in the x direction. So again, try really hard to make it look like a circle-ish. We're just going to give it an inner loop right there. Next one. When you see this number, and I know this graph kind of looks like this graph, but that number 3 makes a huge difference. It turns it into a rose with 3 petals. Rose with 3 petals oriented in the x direction, okay, or one of them is anyway. So you can look at it this way, and this number tells you how big it is. So 1, 2, 3, 4. You can kind of imagine a circle of radius 4, and that can kind of help you if you're, especially if you're drawing it on polar graph paper that has the circles. But your rose with 3 petals, that first petal is going to be there. But since there are 3 petals, they're going to be equally spaced, so 120 degrees apart. So at 120, there's going to be another petal at 120, and add 120, you get 240. There's going to be another petal. So just make sure they're equally spaced right there. The next one is also a rose. But this time that 2, remember the rule is it's going to double. When that's an even number, it's going to have 4 petals. So that's a rose with 4 petals. So again, it goes out 4. 1, 2, 3, 4. And you can kind of picture a circle of radius 4. I don't really want that circle there, but that helps me to draw my rose with 4 petals. You're going to have one here. They're going to be 90 degrees apart because there are 4 of them. So it looks something like that. Next one. You got to know this one. I think that's the most basic one. R equals 4. Radius equals 4. Yes? You do, but you still have to know what they're called. Okay? So, yeah, you still need to know. And this one, I mean, it'd be obvious if you could graph it on Desmos and just, you could see that it's a circle. But I would love for you to know that that's a circle without any kinds of tools. Okay, that's kind of the goal, is to know that's a circle of radius 4. 1, 2, 3, 4. You've got a circle of radius 4. Now notice the difference between this circle and the first circle. This circle was in the x direction because it's a cosine. This circle is just a regular circle centered at the origin. Now H, I'm not even sure if we mentioned this one, but just in case it comes up, 4 theta is a spiral. And then the next one is a line. We didn't spend a whole lot of time on those. I'm not too concerned on that, but if that comes up, that's what you're looking at. Convert. We didn't spend a lot of time on this either. Okay, convert the equation from rectangular form to polar. So remember, rectangular is xy and polar is r theta. So if we want polar, we want r and theta. Anytime we're converting, we use those formulas, those conversion formulas. R equals square root of x squared plus y squared. I believe on the formula sheet, it squares both sides. So both of those equations are pretty much the same. And tangent theta equals y over x. So when you look at this first one, people don't know what to do, but it's really not that hard, because you've got x squared plus y squared, okay? X squared plus y squared is equal to r squared. So you have r squared equals 5, okay? If you square root both sides, you can see that that's a circle, all right? That's a circle. But maybe you knew that was a circle ahead of time. That's a circle. But now we've got a circle in polar form. So then the next one, y equals 2. Obviously, y equals 2 is a line. Go back to algebra class. It's a line that looks like this, right? That's a line. But if they want polar form, then we've got to get an r and a theta in there. Well, we've got a y, so we know an equation for y is r sine theta. So basically, we can say y is r sine theta. So if r sine theta equals 2, let's iso the r. R equals 2 over sine theta. That's the equation of a line. Now, if you go back to the last slide, down here at the bottom, the line, that looks an awful lot like the equation we just had. This one's just got a cosine in it, so it goes in the opposite direction. But we're talking about a line right there. Convert the equation from polar form to rectangular form. Well, we've got an r, okay? We've got an r, so we know r is square root of x squared plus y squared right there. So just do a substitution. What I would probably do then is get rid of the square root. So let's square both sides. X squared plus y squared equals 64. We can see that's a circle, but we knew it was a circle before. R equals 8, that's a circle. That's a circle of radius 8, that's a circle of radius 8. Okay, and then this one, part B, this one's definitely the hardest one, conversion. I don't anticipate this being on a test, but this looks like a good bonus question. If you wanted to convert, what you would actually want to do is multiply both sides by r. Okay, and maybe it becomes clear after I do this step. You may be wondering why I put the r in the middle. I put the r in the middle because it makes it obvious to me what I'm going to do. I know r cosine theta is equal to x. That's one of my conversion factors. So I just changed that into an x. R squared was x squared plus y squared. That's one of my formulas. X squared plus y squared. So I've already got an equation with x and y in it. I might subtract this over. This is going to be a good review of college algebra. We've got an equation. Technically, we would probably complete the square. So we've got x squared minus 4x plus blank. Half of that number is negative 2. Square that number is plus 4. Okay. And what? I added 4 out of nowhere, so I'm going to add that 4 to the other side as well. Okay. I've got x minus 2 squared plus y squared equals 4. And you're supposed to notice that that's a, I guess that's an oval, right? Oh, no, actually, that's a circle, isn't it? That's a circle, okay? That is a circle with radius 2 and center at 2, 0, right? But that's exactly what this is. That cosine, 1, 2, 3, 4, that's a cosine circle. So that's a circle with radius 2 and center at 2, 0. So whatever, this is our rectangular form.